Okay, if you review it from your textbook, actually there is an explanations about how to use the focus to draw a good ellipse. So I will give you a reference to another video how to graph ellipse neatly, of course, by using the foci. Okay, since I cannot show it, it's very hard for me to show it. So, okay. But I want to discuss more about what is the focus, or in plural it is foci, and what is the focal radius. And I want you to take notes from this one, geometrical definitions of ellipse. So let's go back here. This is something interesting about focus, okay? See, the focus is two coordinates on the major axis. See, so they are always on the major axis. Since this is a horizontal ellipse, the major axis is this one. Okay, so focus will be on the major axis always. So if your ellipse is the vertical one, the vertical ellipse, the major axis is the vertical one, so the focus will be on the vertical line. So back to here. So the unique thing about focus is, first, the distance from this focus to the center will be the same with the distance from this focus to the center. Okay, so this distance will be the same, and the term of this distance will be focal radius. So focal radius means the distance of focus from the center, both sides, both focus. Okay, so it can be plus, it can be minus. Second, if you draw a line, a straight line from one focus to one specific coordinate on the ellipse, and then draw the second one from the other focus to the same coordinate. So we have the first line which length is d2, and the second line which length is d1. If you sum d2 and d1, it will consistent whenever you project these two lines to other coordinates on the ellipse. What I mean is, so if I have this ellipse, okay, I'm sorry with this. So if this is your focus, so if this is D2 and this one is D1, D2 plus D1 will be consistent whenever you project the straight line to other coordinate on the ellipse. So if this is the case, it is D2 and D1, the sum will be the same with this. So it will be the same also if I project into this coordinate, and so on. So whenever you project it like this, it will consistently the same. So the other thing about focus, if you project the straight line to this end, okay, let's see. If I project the two straight lines from two focus to this end, it means the D2 will be the distance between this focus to this. Okay, so it will be the sum of the distance between here to here, add from here to here, add from here to here. Okay, and the D1 will be only from here to here. So actually, if I sum this distance with this distance, it will be equal to the distance from this end to this end. Since D2 will be the distance from here and here, so this empty one will be filled with this the D1. I hope you understand my explanation. So actually, from this point of view, we can have a conclusion that D2 plus D1 will be equals to the length of your major axis. So it's the length of your major axis. Or it will be 2 times, for this kind of ellipse, 2 times of the radius of x for this specific case. So after you keep in mind that the sum of D1 and D2, the sum of this one will equals to the length of your major axis. Now if I project this these two straight line into this top end, okay, and let me just say that this is an ellipse with our x equals 5 and our y equals 3. So we know that this is our x equals 5, this one our y equals 3. So please don't mind with the 4, because actually this is what we are looking for. The fourth thing is the focal radius. We want to try to find what is the focal radius. Okay, now because you keep in mind that the sum of this will be equal to the major axis, it means when I project into this spot, the length of this will be equal to the length of this. It means d1 will be equal to d2. It means d1 will be equals d2 will be equals half of your major axis, or it will be equals to rx equals to 5. That's why this length will be 5. And we know that this height will be your ry, 3. Since this is a right triangle, so we can use the Pythagorean theorem to find what is the base, which is the focal radius. So we can find it, it is 4. That's why we have conclusion, this one. If A is the length of semi-major axis, and B is the length of a semi-minor axis, and C is the focal radius, then D1 and D2 are the distance from a point on the ellipse to the two foci. Foci is the plural of focal radius. Then this is the relation between D1, D2, and A. A is the length of semi-major axis. Semi-major axis means half of the major axis. Okay, so yeah, these things is the conclusion. And the other thing that you have to keep in mind, the foci or the focus points will always be on the major axis. So I think the examples on the book is very clear. So I want you to really read and learn it, how to find the focal radius if you know the Rx and Ry. The most important thing is the focal radius speaks about the distance between from the center to the focus. So you keep in mind that you still have to find the coordinates. So happy learning. Read more from the textbook, and you can find other materials from the YouTube or any other sources.